Welcome to qnawire.
Okay, so buoyancy force B is given by the density of the water times the volume of the balloon at our depth times G. Okay, well we can look at a couple other equations to solve for V2 because it's the only variable we don't have. So first we can look at a modification of the ideal gas law. So P naught VI will be equal to P2 VI, V2, and we can express P2 as P naught VI over V2. And now we can look at the pressure buoyancy equation. P2 is equal to P naught plus rho W GH. And we can plug this in for P2 and solve for V2 that way. So P naught VI over V2 is equal to P naught plus rho W GH. V2 becomes P naught VI over P naught plus rho W GH. So now we can return to our buoyancy equation. So plug in for V2. So we'll get buoyancy equal to rho W G P naught VI over P naught plus rho W G H. And that's for A. Now for B, as the depth decreases, what does buoyancy do? Well, you should see that buoyancy and depth h are inversely proportional. So when h gets bigger, the denominator gets bigger, therefore B, our buoyancy force, gets smaller. So actually, as h increases, buoyancy goes down because it is inversely proportional to B. Now, part C asks us to look at half the buoyancy force at the surface. So the buoyancy force at the surface, B surface, is going to be the density of water, RW, times the volume at the surface, which is VI, times G. But we want half of that. And we need to set that equal to our buoyancy force we found in part A, which is rho W G P naught V naught over P naught plus rho W G H. Right off the bat, we can cancel a handful of terms. Oh, this is supposed to be VI, excuse me, but we can cancel that out anyway. And we are left with 1/2 is equal to P naught over P naught plus rho W G H. Multiply each side by P naught plus rho W G H and get P naught over 2 plus rho W G H over 2 is equal to P naught. W G H over 2 is equal to P naught over 2. 2's will cancel out. And you should find that H is equal to P naught over rho W G H. Rho W G. We can actually plug in real values for these numbers because they are pretty well known. So rho naught is 1.01 times 10 to the 5 pascals. The density of water is about 997 kilograms per meters cubed. And of course G is 9.8 meters per second squared. And that height turns out to be about 10.3 meters.